Hi, everyone. Today we're on Unit 7, Lesson 5. We're going to be solving log equations using properties. Before we begin, let's start with a little do now, something real simple that we should all know how to do. If we're asked to solve the equation log base 5 of 1 over 25 equals x, by now we should all know that we're going to rewrite this in exponential form. So we're going to write 5 to the x equals 1 over 125. And in order to solve a problem like this, if you can't see it right away, rewrite each side with a common base. This common base happens to be 5. So to rewrite 1 over 125 as a power of 5, it's going to be 5 to the negative third power. Cancel our bases, and we get x is equal to negative 3. And remember, we just give a quick check. Since our variable was on this side, it doesn't matter. Okay, these are the ones that have to be positive. So we're okay, and we can keep our answer. All right, so up to this point, we've reviewed some basic concepts of log functions that you should remember from your Algebra 2 class. Today we'll be going to be using these concepts to solve more difficult log and exponential equations. I want to point out to you that these are all equations you already know how to solve. Okay, so this is still really a review for the most part. We just want to keep in mind, we want to remember that log base b of x equals y really means b to the y equals x. So we have those two forms. And if you're having a problem with that, remember, you can always think of it like this. B to the e equals n. So I have our base raised to our exponent equals some number. Okay, but it spells Ben. That might be an easier way for you to remember it. Whatever you have to do, this guy here, knowing this is going to be the key to your success in this unit. We studied a couple of properties before break. The three most important properties that we will be using for this, for this next section is log base b of m times n. So when we multiply like bases, we add their powers. When we divide like bases, we subtract their powers. Remember, a log is a power. A log is an exponent. And when we have a power to a power, we can multiply. We bring that power down in front. Today, we're going to introduce a couple more properties. So if m equals n, then we can put the word log in front of each of them. Log base b of m equals log base b of n. This works with ln as well. So whether you're writing the word log with some base or ln, it's going to do the same trick. Log base a of m equals log base a of n, then m is equal to n. If two things are equal to each other, then their powers are equal to each other. That's all it's saying. Okay, so we're going to use this when we solve our different types of equations. And here are the three main types of equations we're going to be dealing with. We're going to have a log equal to a number. So we'll have the log on one side and a number on the other. In that case, we're going to simplify using properties of logs, rewrite in exponential form, and then we solve and check because our original problem has a log in it. When we have a log equal to a log, so when you see the word log on each side, you basically simplify each side using properties of logarithms, cancel out the logs, solve and check. Again, check because you have a log in the original problem. And if we have a number equal to a number where there's no common base, we're going to put a log on each side. So that's this situation here. We're going to put a log in front of each term, solve for x. Here, we don't necessarily have to do a check because the original function, the variable, is in the power. So the domain is all real numbers. So we don't really necessarily have to do a check, but you can always do one if you want. So let's jump right into some problems. Okay, when I look at these problems, when I'm going to start them, I look to see what I'm dealing with. I have log base 5 of x plus 6 plus log base 5 of x plus 2 equals 1. So basically what I'll do is I'll try to simplify this first. That's where I always begin. And then I look to see what I have. Log base 5. My plus tells me I'm going to multiply the arguments. So I have the word log on this side and a number on the other. So I'm dealing with the first situation. So I'm going to write this in exponential form. So I have 5 raised to the first power is going to equal this entire mess. Okay, it's going to be the whole entire thing. 5 to the first equals x plus 6 times x plus 2. So 5 is going to equal, I'm going to FOIL this out, x squared plus 8x plus 12. And now I'm dealing with a quadratic equation. So I get everything on one side and set it equal to 0 on the other. And now I can factor this guy. X plus 7 and x plus 1 equals 0. So my two solutions are going to be x equals -7 and x equals -1. Now remember, since this was, since the variable is in a log expression, we have to go back to the original and check each number. And it's got to be greater than 0. When I plug in -7, -7 plus 6 is a negative number. So I will reject this. When I check -1, -1 plus 6 gives me a positive. That's good. -1 plus 2 gives me a positive. That's also good. So x equals -1 is my solution. Moving on to example number 2. ln of x plus ln of x minus 4 equals ln of x plus 6. Again, I like to always start by simplifying and then I determine what I'm dealing with. So I have ln, the plus sign in between the two logs tells me to multiply the arguments. And now I have ln and ln. I have a log on each side, so I can cancel the logs. And just now the resulting equation is what I'm solving. And now you're just going to solve this the way you would if you started at that step. X squared minus 5x minus 6 equals 0. We're going to factor this since it's a quadratic. And I just want to remind you here, if you get a quadratic and you can't factor it, you can use the quadratic formula. Don't forget you have that tool. X minus 6, x plus 1, I believe that does it. So x is going to be 6 and x is going to be -1, but those are the solutions to my quadratic. I have to make sure they check in the original. So we always go back up here and we look in our original arguments. When I plug in 6, I'm safe. When I plug in -1, it fails in the first check. Okay. So those are some easy, quite easy examples. Let's look at another type of equation. So now this third example, 2 raised to the x power equals 5. Now, if this was 2 raised to the x equals 4, I'd be okay. I can rewrite it. But if you notice the 2 and the 5, they don't share a common base. I can't rewrite it with a common base. So instead, I'm going to use the property, right? Instead, I'm going to put a log on each side. If m is equal to n, then log base b of m equals log base b of n. And I'm going to mention something right here. Okay. I like to use ln for everything. It really doesn't matter what you use, but I prefer to use ln because when we get to our application problems and when we're dealing in calculus, we basically are going to be dealing with ln all the time. And if you don't trust me, do it with both. I might actually do it with both right now. So I have 2 raised to the x equals 5. ln of 2 to the x equals ln of 5. I write the word ln on each side. And if you want, we could do it with the log as well. Log of 2 to the x equals log 5. And again, when we write that log, it's really log base 10. Bring your power down in front. X ln of 2 equals ln of 5. To get x by itself, we're going to divide by ln of 2. So x is really going to be ln of 5 divided by ln of 2. Okay. You don't cancel the ln's. It's not 5 halves. It's the ln of 5 divided by the ln of 2. Those are numbers. So if you were to go to your calculator, wonder if I should do it. Let's see. So I have ln of 5. I'm actually going to hit enter. That's 1.60943. Let's see if ln of 2, I wanted to just pull up the calculator. And that's 0.693147. Etc. Okay, so if you were doing this on your calculator, now I'm going to do it with the actual ln of 3 divided by ln of 5. I'm just doing this to show you that this 1.6 is e raised to that power gives you 5. So it's using the powers, their numbers. And the overall answer would be 2.322. Okay. Notice we're going to start rounding to 3 places. I believe I've talked about this already this year, but we definitely want to start to get rounding to 3 places. Let's finish it off with the log so you believe me and you trust me that you get the same number. So x is going to equal log 5 divided by log 2. Okay. So if you hit log 5 in the calculator, you're going to get a number. If you hit log 2 in the calculator, you're going to get another number. It's just going to be a different number than you got with the ln because now we're in powers of 10. So if I hit log instead to evaluate, log 5 divided by log 2, I still get, though, my overall answer is 2.321. Oh, sorry. 2.322. Okay. You will get the same answer. Okay. But I would definitely, if I were you, I would definitely start using LNs as a way to evaluate because that's really what you're going to be dealing with in the future. In example 4, this is just a teensy-weensy bit more complicated. Okay, we just have to remember anytime we're dealing with an exponential equation, we need to isolate the base first. No matter how small or big the number is, we just have to get that base by itself. So we're going to divide each side by 8. 3 raised to the x power equals 5 over 8. It doesn't change what you do, though. Okay, leave it 5 over 8 because ultimately you're only going to be pressing buttons in the calculator. I'm going to put an ln on each side. Bring my power down in front. Solve for x. And x is going to equal ln of 5 over 8 divided by the ln of 3. And now it's also important to mention here, okay, this is a valid answer because each of these is an actual number. However, we've just gotten in the habit of solving things completely. I'm trying really hard just to drag my calculator out, but it won't drag out. So we're going to do, what was that again? ln of 5 divided by 8. And I'm going to take that answer and I'm going to divide that by ln of 3. And I get negative 0.428. And there's your final answer. And I should write this actually a little bit neater. And more obvious there. I'm sorry about that. So that would be your answer. Now, why don't I have to check this one? Because I know I can plug a negative value in. Okay. And if you don't trust yourself on the math, go ahead and plug it in your calculator and give it a check. There's no harm in that. Okay. So let's try one more example before we're done with the day. This next one's a teensy bit harder. So I have 4 raised to the 1 minus 3x. I have 5 raised to the x power. Both sides have a variable in it, and I cannot rewrite them with a common base. So I start by putting a log on each side. And now I'm going to bring the power down in front. So remember, this is together that power. That power is going to be moved down in front. That stays together. And my goal is to solve for x. So I have an x on each side of the equation. So what I want to do is I want to be able to move my x's around. So I'm going to distribute ln of 4, right? I'm going to multiply by the 1 minus 3x ln of 4 equals x ln 5. And I still want to be able to get the x's on one side together. So I'm going to add the term that has the x in it over to the other side. Now, these are not like terms. So it's x ln of 5 plus 3x ln of 4. But what I do have is I have an x in each term, so now I can factor that out. Except I'm spastic, so I'm just going to rearrange. I like to have my stuff on the left side. So I'm going to take this x and I'm going to factor this out. And really, don't be scared. That ln of 5 is just a decimal. You can write the decimal or you can write it as ln of 5. Okay. I just prefer to write it as ln of 5 until the very end. And in order to get this by itself, I'm going to divide by this entire quantity. So x is going to equal ln of 4 divided by this entire quantity. And we can plug that right in our calculator to get the value for x. So let's go ahead and jump to our calculator again. And I have ln of 4. Actually, I might set it up as a fraction just so I have a top and a bottom. Because remember, with the calculator, it's really important where you put those parentheses. So my numerator is ln of 4. And my denominator is ln of 5 plus 3 ln of 4. And your answer should be 0.2403. 2, 4. It was 0, 3, so we can do 2.4, 2.40 or 0.24 is okay. Either one would be acceptable. Alrighty. So that's really all I wanted to get through today. But please do yourself a favor. Make sure you do your homework tonight. If you don't know how to solve these, set these up and solve them. You are going to be doing yourself a huge disservice. Okay, so make sure you do your homework tonight. Alrighty. Thanks and have a great day.